Okay, the plan is the following. We will use the same file which we did yesterday, and then I will add the code. Actually, I have already added, so I will show you the portion of the code which generates the header files. Not a header files, it's only one single header file. And then I will show you the code on ESP32 side, which is written in C. So this is on Python. Header file is generated .h. Then that will be used by our C program written for ESP32, but actually it doesn't have anything specific to the processor. So it is actually a pure C file. I also verified it that it works on Arduino Mega. Okay, straight away you can compile it and run it on Arduino Mega. STM32, I have STM32 board, which is ARM based, ARM Cortex 4, I think. So M4. So it runs on the same C file that we have, can directly be made to run on any embedded processor, provided the memory that is needed for the hyperparameters are available on the processor, okay, embedded processor. So what we are planning to do is, we are going to use Spider and TensorFlow, Keras to build the model, train the model, and make sure that it is giving the output that we want. Then extract the hyperparameters, which are nothing but weights of the nodes, the connections, tensors we have, and the biases of the nodes that we have. Only these weights and biases of the whole network is extracted out. So we are not leaving out anything. We are not making it into a TF Lite model. TF Lite is a lightweight model. So it actually removes some of the size limitations. Okay, actually it is making the model into a smaller one. Okay, TF Lite. In this exercise, what we are going to do today, we are not making it into a smaller model. So exactly the same model is transferred to the embedded platform. Only difference is we do training here, but we only do inferencing here. Okay, that is what is normally done when we say embedded AI or edge AI. It is nothing but the model which has been trained somewhere is ported onto the embedded device, IoT device, and the inferencing only happens there. So as I mentioned to you, building a car is equivalent to building the model, and driving the car is equivalent to inferencing the model. So we are only querying the model to get some output. So we are not modifying any hyperparameters during the inferencing. We are only giving some input and then see what is the model is giving us, and then we will be running it. So it's a lightweight in terms of execution. So that is what we plan to do now. Okay, I hope this is clear. The reason is we don't have any specific to the processor in the C file, so it can be easily compiled for Arduino Mega or STM32, and of course we will be using the same Arduino IDE only to compile it. Only thing is, once you choose a different processor, it brings in the background different compiler. So it compiles for either Arduino Mega or STM or ESP32. So we will not even change the IDE, whatever we have. The same code, if you change the board and compile it, build it, and upload it, as long as the memory is there sufficiently on the board, it will run. Okay. In fact, before even uploading, you can just see whether it compiles or not. If it is compiling, that means that it completely creates an INO file. That means it is whatever data you are using is sufficient, is small enough to be put into the platform. Okay, I will explain you a little bit more. So this is the plan. Now let me summarize what we did yesterday. I am not going to go into the details of what we did. We decided some 5-node model just to understand how different constants are coming up. Okay, this is layer 1, which are having 5 nodes. Then layer 2 has only 2 nodes, and of course it's a dense model, so input is given to everybody, as well as all the output of each of the layer 1 nodes are connected to both the nodes of the layer 2, and outputs of both are connected to the node at the output. There is output node also, and all the nodes are having the ReLU as our activation function, and MSE is our loss function. So this is what we did. We built the model. Then we saw the code of extracting the hyperparameters. That means all the weights and the biases of each of the nodes. We stopped there. Now what we are going to do is we will use the same code. There we were writing it like this, okay, and then last entry we were writing it something like this. Now what I am going to do is, if we are extracting a weight, we will be extracting weights of this layer, which is, I will call it as W1, and then this I will call it as W2. Between 1 and 2 is W2. Input, there is nothing node. Actually input is multiplied by a weight, which is W1 weight, and then biases we will call this as B1, layer 1 biases. Biases of layer 2 is called B2, and this will be called as W3, and this will be B3. Okay, I hope you understand. The input is multiplied by some weight here, 5 weights. So W1 will have 5 floating point constants, okay, floats. Okay, then B1 biases of 5 nodes, that will also have 5 floats. Then W2 is how many? We have 5 and 2. So all 5 weights, this is L1, this is L2. Each of them are having different weights connected to this. So that is 5 weights will be there. And then this node is also connected to all the outputs of this nodes. So plus 5. So we will have 10 entries, 10 floats we will have on W2. Then B2. B2 is what? B2 is this. B2 is the weight of the layer 2 nodes. There are 2 nodes, 2 biases will be there. So 2 float values. And then W3, both outputs are coming to the output node. So W3 will have 2 floats again. B3, there will be 1 float value, because this last output node also has a bias. Only thing is there is no ReLU or anything here, but bias is there. So there is a 1 float. So these are the different values we will be extracting out, and then we will use them in our ESP32. I will show you the code and then we will see. I hope this is clear. Let me see if there are any questions just behind me. Okay, nothing. Now let us look at the half wave. What did I do? Half wave means I am generating only between 0 to pi. We have 5 nodes, 2 nodes. Only 100 training is enough, because we are not seeing any improvement in the output. And then samples are 1200. Everything is straightforward. So let us just run it once completely. Okay, so while that is running, what I should do? Okay, I cannot do anything much. Okay, let me see whether what I have shown you is correct or wrong. So this is 5 I said. So both are 5 plus 5, 10. I said this is 10 and 2, 12. I said 2 plus 1, 3. Okay. So totally there are 25 hyperparameters. I hope this is clear to you, because this is must be clear before even we start off. Okay. Biases and two biases, L1, L2, I am saying layers, 2 layers. I have taken a simple note so that you understand it exactly what is happening. Okay. So this is clear now. By the time now our output should be ready. Okay, what is the output? This is the output. Very simple model, so it cannot predict more than this. We have only 7 nodes. Now we have to understand the code which is accessing the weights. So let me, just for the completeness sake, let me recap what we did yesterday. Okay. Now, okay. Okay, I cannot expand it further. Okay. Now, let me tell you, this kernel 1, what we call it as kernel 1 is, you have to, as you know, remember that kernel 1 is nothing but weight 1, weights of the input layer. Input, okay, input is given, input is coming to 5 nodes of the first layer. So this is called kernel 1, these weights. There are 5 entries, 1, 2, 3, 4, 5. I have printed it like this, okay. And bias 1 is also 5 entry. Bias 1, this is B1, I call it as, this is W1. B1, there are 5 entries. You can see those 5 entries are coming here, okay. Now this is a little bit confusing entry, that's why I have chosen two different values, a number of nodes here, to make you understand how it is internally storing them. Now this is what our layer 2, okay, this is layer 1. This are the 5 values, and then another set of 5 values are there. Now biases are 2. This is, you can make out from this column is L2, number of nodes in the layer 2, okay. Number of nodes 2 is coming here, so column is 2 column. So this is, let me call this as L21, sorry, layer 2, so N21, N22, layer 2, node 2, first node, second node. So this is column number. We have 5 entries belonging to these 5 nodes. That means the output of them are multiplied by these weights which are appearing in these places, okay. If I call it as, this is the first node, so W, okay, numbering is difficult, I don't know, because convention will be different, so I don't want to confuse you guys. So you can just map it that these are all the 5 values in the same left to right order. These weights are shown here, which are coming to the first node, which is N21. Then N22 has 5 weights which are listed like this. So if you are accessing this particular entry for a particular node, you have to use some I comma j. So I will show you the code and then explain you how we are accessing these values. Okay, so this is how it is structured. This is how it is internally stored. So I just printed out the extracted value, then according to that I was extracting the constant. So I'm sure you will be able to understand that this is the list object. Each row is a list object which corresponds to the output coming from a particular node in the first layer. Okay, and then the next list object is this, and each of those list objects will have output weights. See, output is there is only one. Please don't confuse that. Output values are different. The output value is only single output, which is computed by ReLU function. But the same output value is multiplied by different constants, which are weights. So we will have different entries of weights. Do not confuse this with the output. They are not output from the node. They are the weights to be multiplied with the output. Now these 5 weights are there because there are 5 nodes, and for the 5 nodes coming to this particular entry, which is N21, is shown here. Similarly, it will give you different weights for the same signal which is going to the other node. It is not going to give the same weight here, and this weight will be different. So output value will be same because it is coming from the same node, but the weight what is multiplied will be different because it is landing into some other node. So these entries are for the destined for another node on the second level. So if there is a third node, suppose if I have a third node here, I would have one more entry here, and all the weights will be different. Okay, so that is how the dense connection is made, right? So this is clear, I suppose. And remaining things are all same simple things which I already explained. That many entries will be there, and you can see that last one will be 2 weights. Okay, last node, which is the output node, will have 2 weights which are shown as W3, okay, or kernel 3, and that is listed like this. Okay, because it is little different. Okay, it is not, convention is different. Okay, the TensorFlow, what they have done, they have now ordered them in this way. Okay, though it is going to only one output, the 2 outputs are coming from 2 different nodes, and they are listed like this. Okay, I think it is same way. They are not changed the convention because we see that whatever is the 5 nodes, they are coming in the row wise. They are ordering it, right? So here also they have ordered it row wise because this is one node, this is the node, and then this is another node. So they have ordered it like this. So the convention wise they are following the same thing based on number of nodes. But only happen this output is only single because we have only one output node. So we have only one single entry ordered here. So they are following the same convention here and here also. Okay, so don't confuse. I confused you. So this is how they have internally structured the values. The TensorFlow is nothing but list of list objects storing those constants, and during the training they get modified, and during the inferencing the model will access these values and then multiply the input which is coming in, and then ReLU function will be applied, and then output will be given. Okay, so this is what is happening internally. Now let us look at the generation part of it. Okay, no doubts. Okay, now let me little bit expand it because it's more important that you understand the whole code. Okay, so this is the portion of the code, Python code, which is generating the header file. So let me first show the output to you so that you know what is coming out from which line. Okay, 2L model, let me okay, this is the output generated by our code. Okay, the file name is half sine 2L to indicate that it is a 2-layer model, and data, model data it is actually, it's a data of the model. So let me just show you this is how this function is what is calling that. We are opening a file and we call this as a half sine 2l model underscore data dot h. Okay, this is the file which is generated for opening. So if already file is there, it will just overwrite the file. If it is not there, it will open it, and then it will open it in the same directory where your Python program is running from. And we are writing into the file using the function. Now what is happening is this function hex to c carry, okay, is actually generating a string which is given a ASCII string, which is the content of the whole file. It is all put into one single string. It's a long string. If the file size is 2 kilobyte, that string length is 2 kilobyte. Okay, so it is generating a string of characters, ASCII characters. Coming out from this is written into the file. That's all. Now, what are we passing to this function? We are passing the model what we have created. I am calling it as 2 because it's a 2-layer model, and the file name that we want this is getting written into, actually the file in which it is getting written into. Now why am I passing this as a string here, not a header file, but I am only passing this portion? Very simple, you might have guessed it. I want to put a if and def. I hope this is very clear to you. We do this if and def only because even if by mistake you include it in multiple places, this header will be used only once. It will be included only once, because first time this constant is not defined. If not defined, the preprocessor will open it. Okay, if this constant is not defined in your program, in your project, then only it will look into the content of this. Otherwise it will go up to the end if, which is here, so nothing of this file will be included. So even if you include it multiple times, this file, header file, because you will be having multiple source file, you may mistake, you may include it multiple times. So this is always protected. I am sure you must be knowing it, but explaining once more is not a harm. So we have to do that. So I need the data, the name of the file that I am going to generate. That's why I'm sending the file name here, which I will be using it to generate this portion of the header file. And then immediately I will inside define that constant. So if I just do the hash define, it is enough. I don't need to write a 1 or 0 or 5 or whatever. This constant is defined by the preprocessor. So then the rest of the code will be processed by the preprocessor and it is included in your source file. Now, if you by chance, if you include it again, hash include again this, if you do, it will not, in multiple times it will not include it. Okay, that's the first thing you should know. So now you know the reason why I am passing the file name, but I am passing a smaller characters, but I am changing it into upper characters inside this. So this is a function hex to carry C array. I need this function, so I have put it packages. Now C string I am initializing with the null string first. Then onwards it will be a plus equal to, keep on adding the content to the string. So if and def, you can see map it. Okay, if and def upper of this file name plus dot upper, then underscore h slash n. So this slash n is required. Next line. Then I am doing the define of this. This line is getting generated, and then I want to give a gap. So 1 slash n here and 1 slash n here. Then I want to write Mauli Shankaran is coming. Okay, I took a wrong file here. Okay, and it's okay, no problem. This header file doesn't have that whatever I generated. So okay, don't worry about it. Thus all these header files are coming here before this constant. Okay, that I have added later on. This file is a little older file, no problem. So what we do, we write all the history of this, because when you look at the header file, you should know when it was generated. So I am doing, getting the local time and then printing it, and I am also printing here just for us to know what is coming out. So what is going to the file is only C string. Then all the tools that we use, I am printing the versions of all the tools that I have added later on, so that you know that which version you have generated this file, and which Python, which keras you used, and NumPy you used, all that are captured here. Okay, it's a very good practice to have this kind of information when you are generating any file, and also to have a caution that this is an auto-generated file, do not edit all that you put it, because by chance when you look at the file, you will know the history of what is there in it. Okay, who generated it. Unfortunately, I could not write the file, the jp, the notebook file name into this, because it involves little more difficult thing, because Python's name you can get it, Python file name you can get it by underscore underscore file underscore underscore. But when you are doing a notebook, maybe it's I figured it out that this is not as straightforward as I thought. I gave up. See, when you have ipynb file, some name, file name, if I want this file name to be extracted in my own Python file, this is the notebook file. Notebook, as I told you, Jupyter Notebook is running in a server client mode, because it's a web application, and this is a client where the kernel, we call this as also kernel, which is a nothing but our PVM, Python virtual machine, which is running here. So whatever J file you write here, it is like a server, and then it sends it to this guy. After compiling, the bytecode is sent, and that runs in the background on the different process. This is a process, server process, this is a client process. Okay, sorry, this is I'm confusing it. This is server and this is client. I'm sorry, this is a web client. So you are writing a program, compiling it, and then running the on the server which is running the PVM. Okay, it's a web. It's a, you know that Colab also has notebook, because the notebook is meant for that kind of an environment where you can run it from the web page. So when you are trying to extract the file name, you are trying to do it from the code which is running here. That is a different process. Not even a different process, it could be a different machine altogether. Okay, it's not even running on the same machine. It could be running on a different machine on the network, and you are writing the file from here, which will be in a local directory here in our client machine. So finding the name of this notebook file, for me to generate the header file to write it on notebook is not a straightforward job. You know, you can do it. You have to run some JavaScript and and send some packet here and back here. All that query has to be done. It's not a straightforward job. Okay, so if you guys know some library which does it, please let me know. I will also learn from it. Okay, so I gave up giving the file name. Otherwise, my intent was to give you the file name also, which is generated the header file. So that would have been easier for you to map it. So we need to do something else to do that. Okay. Now you may wonder, why am I doing all this? Okay. It's very natural to ask. Let me tell you two reasons I have. Okay. One thing is, I want to know, or in fact, I want you also to know, how does the TensorFlow 2.0, we don't know what it 1.0 did, is storing our model parameters inside. Okay, that is one thing. How does it store it? So extracting that will help you to know how is it doing it. Second thing is, when I am passing an input, at least the inferencing part, okay, I don't know how it is doing the training part, at least the inferencing part, what exactly happens inside the node. Okay, it is only for regression, and it is for sequential, and it is only for dense network. But what you learn from this is the same thing what will be happening for other network also. Maybe a little more complex, it is different, little more different, but the philosophy will be same. So I wanted to explain to you, using the C code, how input that you give X is coming out as Y by passing through different accessing the different constants, and then ReLU function, all that. Okay, that's the purpose of what we are doing now. Now, second thing, now one question is, can I do it for every model? No, you cannot do it. This is only for, I have done it for 2-layer model as well as 3-layer model. That means 3 layers of models are there, output, input. Okay, I thought I will give you an exercise to add this. Okay, take this code. Assignment 4 will be this job, adding a third layer here as well as on the C code side. Okay, so that you are successfully able to build a 3-layer model, and then you are able to port it onto C. In fact, if you do it on ESP32, it is true for anybody. It will give you a clear idea of how things work, and in any job interviews you can claim that you did this because if you do it yourself. Okay, even if I explain it any n number of times, doing it yourself is always good. So that is my intent, not to just harass you or try to trouble you, but it will actually, during this time I faced a lot of issues, lot of careless mistakes I made, and then learned from it. Okay, I'm sure it will not be very straightforward unless you are very careful coder. I'm sure all of you are participating in competitive coding, so it is not very difficult to do it. Okay, because I'm going to explain everything in a very clearly. So and you have a working code, so it is not very difficult to do it. I'm not saying that it is trivial, but it is tough, but you will enjoy it. Okay, so I suggest you seriously try to do whatever you can, and do not give up. Even if you want to submit halfway through also is fine. It's not completely working, but this is what I did. I really appreciate if you have made an attempt to do it. Okay, so please try to do it. It will be a good exercise for you. Okay, let me see whether any questions have come up here. I don't see anything. Fine, now let us see what I'm doing here. Okay, let me open the header. Yeah, go ahead. Yeah, go ahead. I hope I can hear you. Okay, okay, fine. Oh, oh. Okay. Purpose of passing the name of the file. Okay. Purpose of F and F. Oh, okay. I thought you guys already know and I am boring you. Okay, fine. Let me explain it a little more detail. Okay. Unless I know, I won't know what you don't know. Okay. A dot C, B dot C, main dot C. Okay. And then you have some data dot H. Now, what you do, you want to, in this file, you want to include uh, data.h and data.h include. Okay, hash include is there. Okay, and then here what I have is if and def data. This is a convention. Normally, whatever is the file name, the capital letter followed by underscore h is a convention. Okay, you can do anything else, but it is always follow the convention because file names will be different. So it is better to use the same file name as the hash define here. If and def data h hash define data h. Now, what you do, you also have main C data dot h. Okay, what happens during the compilation? You want to compile and generate a dot o, b dot o, of course main dot o, and then link it library sddlib or libc or whatever, include it, linker and executable. Now, when you compile this guy cc, it the compiler calls the preprocessor first. Preprocessor handles all the if include hash defines. They are all handled by the preprocessor. Preprocessor is another tool before the compilation. It's like before the prime minister comes, the security cleans up the thing, dogs are brought and the sniffer dogs, and they clean it up so that the king can come or the prime minister can come inside. So preprocessor is something like preparing the source file for the compiler to start doing the job. So the preprocessor's job is to handle all the if all the something which are starting with hash if def, hash defines, all those things are handled by the preprocessor. So now hash include is seen by the preprocessor. So it searches the include path. You might have given -i and then include path. So it searches the include path, goes and searches for the file that you have given. Okay, if it is like this or like this, if it is like this, it will look for the library standard library path, and then if it is a double quote, it will look for the standard user header files. It has a different path for it. So it will look for the path means it will look for all the directories that you have given in the same order. It will search for this particular file. Where it finds the first time, it will stop there. It will not go further. So it sees that hash include is there and it has to open it, because its job is to prepare the file for the compiler to do the job. So hash include makes the preprocessor to look for the data h and it opens it. Now before opening it, it will of course process this also, because you may have another hash include inside. You may have multiple include. So it will look for preprocessor processes the file, and if you have another hash include, it will go recursively compute, open the file. It is a blind job of the preprocessor. Now when it opens this data.h, if and def, so it is this instance of the preprocessor when compiling this particular header file, compiling the C file, this instance is having some constants already defined, including some path variable, environment variables, all those things have come already to it. Also all the constants that you are defining in your file, even if you have a hash defined pi is equal to 2 into 3.14 or whatever, 3.14, so it will, all those constants are defined and it is maintaining them in the instance. So it is saying that whether this is already been defined, that means what, you are supposed to not to use this constant anywhere else in your program, okay, or in any other header file. If you do so, then you would have defined it and then it will not even open this file. Okay, that means it will open the file but it will not include the content of this file. So assume that you have not done that kind of a mistake, and this is the first instance of this header file coming here. So it will see that it is not defined yet, and then it goes down. If and def means if it is not defined, then you go further till you encounter the end if. Okay, this is end if. Till you encounter the matching end if, include whatever is here in your place where it has opened the hash include. See, it has opened the hash include while opening the a.c. So in this place, instead of this, it is going to include all the contents of this here. It is going to just add it to the file, because that is what the compiler is going to see. It is not, compiler is not going to see what you have really only written. It is not, even compiler will not even see the hash includes at all, because before that preprocessor expands everything, and then if you have a hash defined, it will expand it and then put the values there, whatever constants are there, it will put those actual values. Pi is defined as some 3.14, it will do that. So when you have if and def, it means that this has not been opened at all earlier, or it has not been included in this compilation so far. So it is coming here and execute this instruction, which is also meant for preprocessor, hash define data h. That means I am supposed to define it. Now it defines it in the means it is understood as a constant, some constant, but it doesn't have a value, so it is not a problem. It is a well defined constant as far as the preprocessor is concerned. So it does it, and then it also does all other things you have put. Now what does it do? If it is not a preprocessor directive, it is some floating point variable, it doesn't understand any declaration or anything. It will blindly include this content in the place where you are included the hash include. So it will put it there, plug it into that, and then suppose you have put hash include my constant.h, then it will go open up the my constant.h and then it will put the content into that. So this is what preprocessor is doing one by one. Now imagine the myConstant.h, okay? MyConstant.h is another file you have included in your a.c, myConstants.h. You are including it here because it is not any crime that you cannot include the same data h file in different places, because you may be using it in another file to compile, maybe x.c you want to compile, and which is needing this my constant is needing this data file also, so you may include it any number of time, no issues. But as far as this compilation is concerned, my constant.h is coming after your data h, okay? You have included multiple times in this case. So what does the preprocessor do? It will blindly open this data.h, okay? It is not aware that it is the same header file which it included. It doesn't remember it. It opens this data.h file and then looks at if and def. Now data.h has been defined already. So this if and def is false now, okay? It is false. So till it encounters end def, nothing happens. So it will go through the file. I'm not saying that it will not go through the file. It will open the file. It will go through the file, because you may have if and def, afterwards something may be there. It has to include it, maybe. So it will go through the file and then end if till that point, it will not include it again. That means what? It has been already included in your case. So it is not supposed to be included multiple times. I will tell you the reason also, because in your data.h file, you might have declared some constant, or not even constant, you have declared some variable, suppose global variable, int g, okay? Now, if you include this data.h file multiple times, the int g will be defined multiple times. And when the compiler comes, that guy will say you are duplicate definition of the variable. So compiler will not like this kind of a nonsense. So it will give an error which it's not be possible for you to find out that this is because you are including this and you have not had this if and def, okay? So it is very, very difficult to understand if you not follow this convention. I hope now it is clear, okay, why it is important to have this if and def in your code, especially when you have a header files. Sandeep, is it okay? Yeah, okay, fine. My story is not over. So now what happens? You are compiling this, the story is stopped with this compilation. It will not include the my constant hash, it will not include this data h again. So it will properly go through your C code of a.c. Hopefully you are written properly, so it will compile and generate the a.o. Now compilation for b.c happens. Now you may have some constants which are variables which you may be using it, which are defined here. Now the preprocessor is calling this again fresh, okay? So this preprocessor is job is done. O is generated, that job is done. So this definition is gone. So it's another instance. When you are compiling a different file, it's a new instance of compilation happening. It's a new process happening. So new preprocessor comes up now. So it will not see that data h was included because that was for the previous compilation. So it will include once in this compilation, and then it will generate, if everything goes well, it will generate the O file and stop it. Here also it will happen like this. Now imagine you are writing this data h file everywhere you are including, okay? Now let me give you one more scenario, okay? Data h file, I am going to see what is written in data h file. Imagine in data h file you have written a statement extern int a, okay? Extern int a, okay, let me call it as a g, okay, global. Now imagine if you have written like this, assume for a while, okay? What has happened when you compile a.c, okay, it has included this data h file as it is, right? So this g variable was considered to be extern, correct? So a.c, when it compiled with with a hash include data h, okay, data h, what did it do? It is using something inside that. It is using some g equal to 2, or something, okay, plus 2 plus equal to, it is using the variable g, but the hash include says it is an external variable. That means what? As far as this a dot c is concerned, g is not yet defined, okay, it is somebody else's responsibility, but a dot o will be generated without any problem, but the generated code has a reference to g, but it doesn't know the address or even the relative address or the even definition is there or not, it doesn't know, because the variable is not defined. It is saying that extern, the header file says it is extern, somebody else is going to define this variable. So the compiler will leave a gap saying that I actually used a code of g, I am accessing the g variable, and then I am adding 2 to it and then assigning to g, but I don't know who is defining g. It's some template is opened, okay, it is a is to be finished by the linker, okay, it's a half finished o file. So a.o is compiled, but doesn't mean that it knows where exactly g is defined or who is defining it, it doesn't know, but done, job is done. Similarly, b.o is also done, because there also is the same data h file is seen, it says external g, okay, someone else is going to define it, I don't care, so it also compiles it. Now b.o also will say that I have using the global file g, but I don't know who is defining it. So now the problem is, when the linker is coming, okay, it is getting a.o, b.o, internally g is defined here, g is not defined here, used here, okay, please remember, used, u is used, g is used means it is like no ldr load, some variable r1 comma this value, okay, some address of the g, but the address of g is not known, okay. So somewhere there is some ldi instruction, some instruction will be there which will load the address of the variable, okay. In that place the variable is not known, okay, where exactly it is located it is not known, so that assembly code what has been generated by the compiler is having some holes in it. That means it has to be relatively, somewhere it will be placed in the memory, and it will be used, it will be filled by the linker or a locator, okay, or a loader, okay, let me call it as a linker only, it's a linker job, okay, let us not go into the detail. So now linker is supposed to get all the obj files and then resolve the what is that called, I forget the name, labels, okay, resolve all the labels of the variables, okay. So if suppose you include all the o files and nowhere else the g is defined, then it will give an error on the linker side during the linking time that this g variable is not there, it's nowhere I can find out, in none of the modules I can find out. So now what is the solution, okay, let me give some crude solution, okay, there are many solutions, I am giving you a crude solution. Main.c is the god of everybody, okay, this is also compiled as an individual file and then it is generating a main.o, but it is also including the data h file. This is the head of all the guys, okay, these are also temporary or not temporary, some side business files, but this is the main file. So normally what happens is we give more responsibility to the main.c file to take care of all the definitions of the variables, especially the global variables. Local variables is not our problem, and static variables defined in each of the modules are not our concern, they are all taken care of by the individual files. But the global variables should be, actually you should construct it that way that the main file main.c takes care of all the global variable declarations. Now the problem is data h is included here also. Now let me see, now what happens, main.c is getting compiled, okay, it is also including hash include data.h, okay. So when the compiler is compiling it, first time preprocessor is coming up, so if data h is not defined, so it is going to include the data h file. But the problem is extern int g is true here also. When you are opening up here in the main, extern is true. Now what will happen is main also will assume that it is not my job to define this variable. because you know very well, if you have a hash include here before the main function is starting, they are all, whatever variable you are defining here are all global variables, right? So if I open the data h file in this place, it is this extern is coming up, int g is also opening up here. It is like, remove this and then replace it with the extern int g. Okay, now the problem is I am still calling it as a extern now. So even this, during this compilation, our friend, our compiler, which is generating the main.o from here, is not going to define this variable. It's not going to consider it to be a global variable defined here because it is extern again. So what you can do is in main.c, what you do, hash define, okay, extern nothing. Okay, you say nothing, don't say anything. What will happen is hash define is also a preprocessor directive and you are defining it in the beginning. That means preprocessor here knows that if I encounter anything as extern as a string, I will replace it with null character. Null, nothing. Now imagine it is opening the data h file now. Here it is also going to see extern int g in the data h file, but it knows now, it is given an instruction that if you encounter an extern, please replace it with null. Now what happens? Int g will be sitting here, not with the extern. So all the global variables will get a life here. In the sense, it will all be defined here. Along with the main.c compilation, your variables are defined. So it is going to be defined only once. You are not going to do this in every place, every C file. Wherever you want to define those variables, you should do that. Or if you don't want to mix it with the main.c, you can also do globals.c file. Okay, all the global variables you capture it here and then include all the variables of different modules. But inside the C file, hash define you do, hash define extern null, nothing. If you do that, then this global.c file will take care of defining all the variables in one place. So it's always safe to have all the global variables in one place so that any memory wise it will all be together, because you are maybe accessing them one after the other, so they will all be in the contiguous memory and you will improve the performance. So that is why you do all this business. Okay, so in a big project what you do is you do it in a different global.c file. So one thing you remember, if you don't do this in the main.c, extern hash define extern and nothing, and then you include hash include, you do that, this compilation will go through. Please don't think that it will not compile. Compilation will go through, but during the linking time, g or any other global variable is not defined anywhere. So unresolved symbols or those kind of errors will come, linker errors will come when you have such problems in your definitions. Okay, global variable namings are very important. It should not clash with somebody names. So that's why I keep telling you, like your parents given your name, you have to assume, when especially even the local variable, I will say that every variable should convey what it is supposed to be doing. Please remember, I have seen the code of your guys. Sometimes I cannot understand your code. I need to spend a lot of time. When you just say L equal to 3, K equal to 2.0, and then M is equal to some double value string, I really go mad to understand this kind of a variable names and different types. Okay, please never ever do, except for your local variables like index I comma j, please give meaningful name. It is not for, not only it is actually, it is confusing for you to debug your code, and it is a nightmare for somebody looking at your code. And let me tell you, you guys are all learning Python and I taught you Python. Python is defined, or the language is defined by the author or the owner of Python, Guido, only to make the maintenance of your code easier. Please remember, he has identified the need for a language which is easy for maintenance is because most of the time what you write in production in the industry, while writing the code, the developer spends some 20% of the time maybe, and 80% of the time, mostly if you are writing some code, which application or library or whatever, 80% of the time is seen by somebody else for maintenance or for doing some changes or enhancement. So what you write, especially if you are writing assignment, please remember that is also equivalent to a customer. Okay, I am like your customer. Yes, exam I will give you some leeway because you are already in a time pressure. I normally don't insist on that, but it should become a habit that even in the exam, you that it comes naturally. The variable names comes naturally to you. It shouldn't be a, like a hard thinking that you need to think about some library, variable name. It should come naturally to you. Beautiful name, even in a hurry. Okay, it is like you cannot say that I am driving in a hurry, so I will hit anybody on the road because my exam is there at 2 o'clock. No, even if you are in a hurry, even in the exam, your naming convention should be in your brain that it should come naturally to you. Okay, maybe you might have seen when I am coding it also. Okay, I never normally don't use some random names in my code. It's not because I got some experience in coding. It is also true, but it is the responsibility of the developer to write a proper code and use a proper variable names. Okay, it's a crime, I would say, if you write code which is wrong, okay, or which is not conveying what it's supposed to. Okay, it's a crime. Okay, even if your code is working fine, if it is not clear to understand by somebody, you are actually doing a crime. Okay, so we were in that event of story. Now we have output all the versions and everything details. Then model details are given, number of epochs, batch size, and then dense one, level 1 size and level 2 size. This is the number of nodes in each level. It will be 5 and 2 for our model here. And you know that this I have already told you. So it basically accesses those constants, and then we use a string here, percentage yes. So I am like a printf only. We have a format string and percentage, and the string followed by the float value, then f as a string. And I'm leaving a comma and then space there between the adjacent elements. So if you look at this output, f float value and then f comma then space, then we fill this whole thing. So this I have already output it. Okay, based on which array I am accessing it, I will output that, because I am accessing layer 0, that index 0, kernel 1 and bias 1. You have to see that printfs are coming just for our sake, and then C strings are going into the file, and we go through the length, we take it so that this code is generic enough for any kind of layer 1 and layer 2, but it is meant for only 2 layers. Okay, it's not that it's generic enough that any layer can be given. But even if it is not dense, it is not a problem here. But I have not tried it, so I don't claim that it will work for non-dense or any other formation. So you can use it for dense connections, or any number of nodes can be there in each layer. But number of nodes is not a concern, because we are taking the length of, we get the length here. See, where is it? Sorry. Yeah, we get the length of that internal list. So you will be able to get actually how many elements are there, and then access one by one and put it out as a string into that string. Okay, add it into the string. Now what we want, the last string, when we want to add, we want to put this last string, we want to say percentage n. Now, that is also same. Sorry, we want to say closing bracket and semicolon, all that we want to do. Okay, for the last string. the float value, last float value. So that's why I am leaving out the last float value of the list and then outputting that with this template. So what will happen is, when you are trying to do here, this is output all the values, and the last float value is output separately in the last line. Okay. And we give a carriage return followed by this closing thing. So this whole thing is done, and then we do the same thing for this. In this way, these two are very easy because it's a single list of values, so you will not have difficulty. The difficulty comes here, okay, in which order to put it and then in which order you are accessing it. Both need to be exactly same, otherwise I had a lot of time I spent, because the code which I had was not exactly matching with the generated code, and it was not working. I had to really dig it out and then find out what is happening. It was little frustrating. So it will happen even if you are doing it even after seeing my explanation. But this is 256, not 256. It will be 10 into something. Okay, I don't know. This may be a longer list. I think this constant is defined. What is it? 16, 24, 16. So it is a very long list. Okay, 24 into 16 are the entries here. Okay, so that's why you are seeing a long entry. I am not showing you the exact output of this file, so no problem. So this is just a single list. Okay, if I have to show you this one, okay, this is the list of one list only it is having. Similarly, bias is having a single list only, so you have to just access the length of this and then print it, output it. So these two are easy, but this is little difficult. Now you know that internally C also accesses a row major, and then our friend Python also does it row major. So putting the values in this order is a good thing. Okay, so if you see that I have followed the row order, 0.070 this value followed by 4498, then 0.76, and then 0.31 minus 0.31, 0.031. So we are doing a row major because our Python follows the same way the C does. It's a row major, so all the row elements are put it in the contiguous space, and then the next row major element. So it is similar to storing it in the memory, but we are actually outputting it onto a C file, and we are doing it like this. And while accessing it, we will also keep it in mind that we are accessing it, we are storing, we are receiving it in this way, so that we have to access it also in the same way. Okay, that is, this only is little more involved and it's not difficult. Okay, so which is the file, code. This is the code which is explaining the list of list. Okay, first we are getting the list of objects. This length of list of object, okay, this length, whatever you get, this length of list, length of list of objects is as number of list objects. You can, okay, let me explain. This is little difficult to understand it. See here. See, I am talking about the node values, weights values, which are like this. Okay, and then this lines. So we saw that it is storing it in this way, right? Two values. Let me call it as A comma B, then C comma D, like this. 1, 2, 1, 2, up to 5, because there are 5 elements. Now this A is here. This is the node N1. I'll call it as N2. This is for N2. This is for N1. So A is coming here. Wait, okay, this is not A is coming. The signal is coming and multiplied by A. A is here. Okay. And then C is what? C is also coming to N1, but it is coming from the second node here. So this is 1, 2, 3, 4, 5. So C is this fellow. And then E, F, if I say, E is this guy. Now, which is B? Very simple. It is to this node, okay? N2, because B is the column is B is for the N2. This is coming from the first node of the layer 1. So if I draw this and this values B, if I draw this and this values D. So this is how it is coming. While reading on my C code side, I will access it in the same way. Okay, I will come back there when I am showing the C code. You will understand it. Okay, once you understand how it is stored and how it is, we are storing it as a B, C, D, which are these values. So let me explain now. Let me also talk about how we are going to process it on the C side. Let us see that this is the input. Okay, X is coming. What we do? We multiply it by X. Okay, and then we compute the input to this. Then ReLU function will apply, and before that we'll add this bias b value. Weight will multiply with X and bias value will add it, and then ReLU function will apply and get the output. So we'll write some value H is the output. Okay, now when you are processing for this, the next layer, this L2 layer output we want to process, we want to compute the output of each of the nodes. In that case, I want to compute the output. What I should know? I should know all the inputs coming from my previous nodes. That means I should get this value, multiply it with A, and then get this. I will have it in an array. Okay, all the outputs I will have it as in some H array, which will be 1 to 5. So I need to get each of this output and then multiply it by proper constants. Now, when I am accessing the constant, I should go this way. Okay, I should go this way. I should pick up this, I should pick up this and this, not in this order. Okay, you have to pick it up in this order because you are computing it for a particular node in the second layer. So that is how you need to compute it. Then only you will be able to get all the values of input coming, and then you would have multiplied with these variables, constants, weights which are coming. Then you will have the bias here added, then find the activation function output. Then you will have another H2, maybe H2, this is H1. So you will have the output ready. So what you should do at every layer on your C side, C programming side, is that if I have an input, what is the value that will be landing, that X will be landing in all these places, and then multiplied by these weights will be the input finally. Then bias will be added to them. Then this ReLU function is applied, output is computed. That you store it in this way, in this H1 variable. Then you have to access these weights and then compute this and store it in H2 array, which is only having 2 entries. Then output is coming to the final output layer. This H2 is multiplied by these weights, and then bias you add it, then compute the ReLU function, then final output. So you have to painfully compute these values, not you, anyway your C program will do, and then you will compute the output. Okay, that is the C function we have written. So if you look at the C function, you will exactly know what does the network do when an input is given to the network. Okay, is there any doubt in the way we are extracting out? Okay, I'm not expecting you to understand this code completely now. You have to read it once, okay, and then understand it. But I hope you understood the philosophy of what I am doing here. Okay, any doubts so far? Can I go forward? Or is it completely overhead, or is it okay? I put in all the effort only to make it clear to you guys that how exactly this network is working. Okay, no doubts. Very good. So if any of you have any doubts, you know whom to go. Okay. So don't worry, Sandeep. I'm not singling out. You can come to me also, no problem. Okay, good. Now at least one confirmation. So you can understand it is not difficult code, I'm telling you. Okay, you guys are all competitive programmers. Fine. Now, well, okay, let me just show you the real output that has come out from this. Okay, I think I have run it right. So let us see that output instead of, okay, actually I should have done that. I'm sorry. Where is it? Okay. Uh, Let me do one thing. I will run it once now so that I can time it, so that you are also convinced that it is generated now. 725. Yeah, half sine wave 725. I'm not cheating. Okay. Okay, let me close that file. Previously something else was open with the same name. No, nothing is there. So let us open it. You better verify once, okay, whether what you are seeing is the same thing which has come here. Okay, 0.1017. This kind of errors also happened in me with me. One, at least some values. Okay, 1.322 something else is okay, and especially longer values, please be very careful whether it is last value and the first values are correct as per this output. That's why I'm printing everything so that you don't miss out on anything. Okay, these are all debugging skills. Okay, you will develop your debugging skills by doing it. Okay, so number of entries, you will know that it is all proper. Okay, I am not going to count it for you. Now what is this? Number of epochs is 100. This is 16. 5 and 2 is correct. Now this is what is the output. Okay, what has been generated. So it is correct only. Now our job is done with the Python now. No, we no longer need a Python's help. We can say bye bye to it. Now what you should do, I will tell you. Yeah, okay. Here only. So preferably, I will tell you one thing. Wherever you are developing this code, okay, um, actually I should have put it in this place. Have a ESP32 directory, okay, so that you know that this is, assume that I have generated here, okay, I did it somewhere other place. ESP32, you open it, okay, so that you know that whatever model you are generating is being used for ESP32. If you have a Arduino Mega, I don't think you need to do separately because this code will work straight away. You can compile it and run it. Then go to ESP32. I have put two different directories, 2 layers and 3 layers, because having a different header files being generated for it. Okay, when you do assignment, you can also do that way, because you will mix, you will be missed out on whether it is a 2 layer header or a 4 layer 3 layer header. You don't know. Okay, so it is better to name it properly so that you don't mix it up. Yeah, that is a problem. Okay, now half sine wave model is here. Okay, this is the previously I generated this file. I will delete it. I don't want to use this file. Delete. Oh, sorry. Oh, okay. Now this I have given the same name just for the thing. Okay, now I'll copy this guy. Okay, this you can, if you decide to do it in the target area, that is also fine. This job is not required, but I have done it this way. No problem. I am copying it here. So this directory is same as the file name, of course, and all the files which are there is opened as a single project. By now you must be knowing it. How does the Arduino knows what are the files to be opened? You keep all the header files and the C files, whatever, okay, in the same directory as where you are having, and the directory name should be same as this INO file. Then it will open everything together. Okay, all the header files, everything, it will open as a project. So now I am opening it. Now this is our ESP32 site code. Okay, it's now, if you see that I don't have anything specific to the board as such. I am using the math.h because I am using sine function. Otherwise, I am not using anything with the board specific header file. So you can compile it on any processor, for any processor. Now let me explain what I am doing in the main. Okay, we are function output of our model is the predict. Okay, and it's a regression model. So input is float and output is float. I'm not using this built-in. You can blink it if you want. Then inference count. Let me explain what I mean by that. See, what I want to do is, I have the model. Okay, I will give X. I will get Y. I will use predict Okay, I'll pass X. That will go through this network and then give me Y. Okay, returns Y. That's all. Predict is the function which is nothing but inferencing. Okay, we are inferencing, we are doing on the model by calling this function, passing the input and getting the output. Because it's a regression model, one input, one output, no issues. I will talk about classification later on, how to use the same code for classification. It's a different code. Okay, it's not the same code. Okay, now what is inference count? Is some variable, global variable, and then inference cycle is 1000. Perform inference using the model with values of x ranging from 0 to 2 pi radians. Now, actually, this comment should be changed because we are having a half wave now, so it should be pi only. So maybe I will say pi. Okay, pi. It is 1000 values. We are going to take it. What I mean by 1000 values we are going to take is similar to our sampling earlier we did in there. I want to plot 1000 values between 0 to pi of x and whatever the predicted value of y I am going to print. So I am going to call the predict function 1000 times. Okay, this is 1000. Okay, inference count. And ranging from 0 to pi I need to make because our model is only for the half wave. Okay, so that also it is not between pi to 2 pi, is between 0 to pi. So you have to be very careful that our range of values of x is going to be from 0 to pi. X range is 0 to 0 is not shown here. Pi, x range is pi. Inference count is nothing but how many samples you are going to run it through. Okay, and then serial begin, you have to be very careful. Use a standard baud rate. Don't keep changing it. I told you already. And then some delay I am having just to make the serial port to settle down. Okay, it's not required, but it's okay. First time in setup. And then this is one thing. If you have noticed, tools has serial monitor and a plotter also. So monitor gives you output in hex format. Plotter gives you the picture, the output waveform. Okay, it can even output multiple waveforms using the plotter. So plotter also uses the serial output values. And when the after the setup, when you do a begin setup, after the baud rate is set up, then if you do print line and then say the things, if you are using the plotter, suppose if you have put it and then you are using the plotter, then it assumes that these values are for the labels of the things you are drawing. So what I am planning to draw, I want to draw two things. One is actual value. Okay, 0 to pi I want to draw, plot it, actual value and then the predicted value. Okay, now this is one value, this is another value, this is x actual. Okay, sorry, y actual and y predicted. So I want to say the labels of this, it will show up the color and then give actual and predicted. Okay, this labels I am giving it here. Okay, and this is supposed to be for the range of values between, no, I want to print it between -1 to +1. It, the documentation says that it is for that, but I don't see that it is actually working that way. I thought I will leave it to you because it maybe this version may be having a problem. Later on you may have the right version and it may work, or I am not using it properly. So this is to actually scale the output plotter between some range. You can do it. Okay, right now it's not actually working as expected. Okay, fine, no problem. This you have done in setup. Now you are going into the loop because you are going to call it multiple times in the loop. What you do, you want to position. The position is the variable which is a x value. I want to find the position like this. This is the position. Okay, this is nothing but a x value of 1000 values. Okay, maximum some 1000 between 0 to 2 pi it will be right now. So these positional values I am trying to compute. How do you compute? Inference count is how much now? Inference count is 0 now to start with. Okay, and then divided by, it's a float. Okay, I'm typecasting it to float, or I could have defined it as a float. I don't know. Okay, it is defined as an integer here. but here this is float, no problem. But these things are defined as an integer because we want to use it as an integer only most of the time down. So it is defined as an integer, but you want to perform a floating point arithmetic. Okay, remember this value should be a floating point output. If you do not do this float cast, it will perform an integer division because both are happens to be integer, and then it will give you 0 most of the time or 1 sometime, okay, based on the values. So that is not what we want. So we want that to be a decimal value. So where inference count is going to increment 0 to 1000. Okay, what is happening is the inference count is going to go from 0 to 1000, and then you are going to divide that by 1000 every time. So first 0 by 1000, then 1 by 1000, 2 by 1000. So you are actually dividing this into 1000 equal part. That's all. Okay, very simple. Once you divide that equal to equal part, you want to give it to directly, you can give it. Okay, that is the position. Sorry, you have to give it in the range. Okay, that division you have to give it in this pi value. So you are multiplying it to pi. So what you get is initially, let me tell you what exactly is happening. You are getting a value between 0 to 1. Okay, 0 to 1 you are getting 0 to, okay, 1000, okay, into divided by 0 by 1000, 1 by 1000, 2 by 1000, like this you come up to 1000. Okay, this value. Okay, this decimal value you are multiplying it with the range pi value. So it will be varying from 0 to pi, or a smaller value is in fact we are dividing the 0 to pi into 1000 small values. Okay, that is what is happening here. I'm sure you will be able to understand. X value you are getting it, then predict the y value. Okay, and then actual value you are doing it with the sign. Okay, actually here we are, because we are restricting the value of x value between 0 to pi, you will get only values from 0 to pi. Y value also will be restricted to 0 to pi. So it's okay to use sign here. Okay, you have to use sign only. Then you plot it. You can print y actual and y val and this. Okay, so let me just then increment the count, and if it is more than the cycle, make it 0 and go on. So I will do one thing. Oh, I should not use this file. Oh, correct. Yeah. Okay. So I will not show how is it doing. So let us first compile it, output it, and see the output, and then look at the code. Okay. Always better to see the working code rather than. Actually, you can even look at this value also, whether it is same as what you have, what your project you have taken. Okay, so it is 0.179, so it is correct only. Okay, it has already loaded. So plotter. Now, if you look at it, you can see that triangular shape appearing here. The problem is it is only showing from 0 to 1. Okay, the value is actually 0 to 1, but my scaling is default, it takes 0 to 6. So I am not able to see it properly, right? How do I make it proper? So what I did, you can do that. Okay, I am multiplying the value, I am enhancing it to, okay, sum by 3. Okay, by it is not going to impact the values. I am actual also I am multiplying by 3. Anything you get, you multiply it by 3. You are enlarging it so that you can get the enlarged output. So that's the purpose. Okay, so don't get confused why I am multiplying. My intent is not to change the value anything, but to see it in a bigger form. So plot it. Now you are slightly better. Now you can see it, right? So this is exactly same as what we saw here. It is only expanded a little bit because it is running like this. If you maybe 1000 samples, if you make it 500 samples, it will be compressed a little bit. You are seeing exactly what is coming down and what is going up. Blue is above this, exactly same picture you are seeing. So there is no distortion here because we are using the same model. We are not even lost anything here. So far, I hope it is clear. Okay, now we have how much time? 20 minutes. I think it should be okay. So this is the I am calling it a CPP. Maybe I should write it as C file only, because it doesn't matter. Internally, this compiler is using CPP. Okay, it's a C++ compiler only. So now what I am doing, this is the header file. I am including that header file in the model.cpp when I am having math.h and our own generated header file. And then I'm reading the array. We are, we are using this as a array of values, float values, right? So to read it, I have defined a function, and we have a floating pointer passed, and the content is returned. Okay, it's like you pass a pointer to it and it will give you a value. I don't know why it should be. Maybe we could have avoided it. I had this code somewhere, taken it and then modified it to simplified it to make it our code to be using with ESP32. It was actually for Arduino Mega. Somebody has earlier written it, but I modified it to use it for our purpose. You can change it. Okay, I don't, and if you're confident, you can modify that, not a problem. Now, every float values that we read, I want to use some inline function. I'm sure you know that inline means it is going to replace it with this actual content. So because it is a, sorry, it's a C++, right? That's why inline is working. Okay, if you guys are not in C, you will not know. If you don't know C++, you don't know. So I'm sorry, I am assuming that you know C++. Okay, in C++, the same preprocessor is coming, and then it has a inline directive, which is for a preprocessor directive, wherein you can, it's similar to a hash defined macros. Okay, you have a macros in C, macros. Okay, because macros will be replaced with the actual code, right? Like a square and all that. So inline is a equivalent of that in C++. So whatever you have inside of inline is actually plugged into the place wherever you are calling. Okay, there is no function call made when you have an inline functions. Okay, it's an optimization wherein it will be removing the return also, it will be removing the function call also, it will replace it with this function. Okay, and this function is nothing but this, which is I could have made this also inline, then it will make that inline. Okay, but don't worry, don't make any changes now. It will call, compiler would have done some optimization because it is only getting the pointer and then dereferencing it, so it will replace that. So it will be replaced with one code. Okay, it is a very simple inline function, means you are replacing it. Okay, now what you do, you want to read w1 value float, because we are finally getting the float value because dereferencing the pointer of a particular value. Okay, you are passing the index and getting the value out of it. So you are reading it from the array. Now the array is, where is it? It is all in our header file. Okay, it is all in the header file. So how does it know? Because you are including it here, so no issues. Now it is going to access the array, and then offset is given to that. Okay, is you know very well, the pointer, the arrays always have a base address, and then you, as a index, if you add it, it will access the next element. Only difference here is it is accessing it this way. Okay, this is for the weight which is between the second layer and the third layer. Okay, so this is the second layer, first layer, the two layer. So this values you are accessing it using w2. This is w2. Now this is accessing it like this. Okay, some two element. Okay, now we are expanded it a row measure, right? So this will be shown like this. Okay, in a row, in an array, C array, it will be expanded like a individual element, expanded like this. We saw that there. Okay, now just see here what you are doing here. W2 is the base. Okay, W2 is the base, and I is using the dense 2. Dense 2 is what? This value is 2. Okay, dense 2 is the value of this number of elements in this number of nodes in this array, in this level. So it is number 2, and dense 1 is 5. So because it is a row major, it is stored like this. For every index, you have to, if suppose you have to access this element, you need to give the offset of two elements, you have to add it to that and then come here, right? So this value, whatever you are getting it at I, is actually passing the I is this, okay, which node output you are multiplying it with. So I is actually this and j is this, and that's why you are multiplying I with dense to value, because you have to give the offset of this much. When you are accessing this, you have to that many number of offset of the this element you have to give it. That's why dense to is multiplied with I, and then when you are accessing the individual values of a particular second row, you are using the j. So this is what is a little more confusing part of the code, which you need to understand it. Okay, um, try to think about yourself, and what you saw there is being read here, so it's not a rocket science, you will be able to understand it. Okay, but for me to figure it out, to make it work, it took some time, but now you have a working code, so it's not a very difficult, and you are going to use the 5 and 2 combination, so you know exactly what is coming out, so you can print the values also and check it. Okay, so the rest of it is very simple, they are all accessing the one list of values, so you are adding the index to it and getting it. So these are all the functions which are accessing the particular elements in from the array. Now let me come to the core of the prediction. Okay, prediction is what is actually going through the array model. So you come with the x value, declare two variables. Okay, let me explain it again. 5 and 2. Okay, outputs of this guys are available on h1. Okay, h1 array of dense 1 size, which is 5. Similarly, output of these guys are available on h2 of size 2. I am declaring as a local variable, remember, and all of them are float. Okay. Now, one more question, one more thing I have to explain to you. We are using the float in our ESP32. Okay. ESP32. It says that, okay, Chinese, okay, I don't want to say anything country specific. Okay. The ESP32 data sheet says that they have a floating point processor inside. If you are using a float variable, okay, it will use the floating point processor to do the performance arithmetic. Okay, it's not using the integer ALU. So double, it doesn't have a support for double, so it will be time consuming, but float is a little bit easier to do on the ESP32. But I read on the internet saying that it is much slower than the STM, which is a Cortex M3 or M4. So ARM processor has a better floating point processor compared to ESP32, is what is the internet analysis says. But I am not saying anything, because if you guys forward this recording to China, I will be in trouble. You won't do it, but I'm saying just joking. Okay, so fine. Now H1 and H2 are done. Okay, these are the output you are trying to get it. Now, how do you process the H1 output? Very simple. This for loop. This for loop is, let me explain it with a separate entry. 5 input is coming here. Okay, the same x is coming, same x. Okay, now where is the variables of weights are stored, it is, you saw that it is in the array. Okay, w1 first element, second element, these weights are stored here. So we are accessing I dense 1. Dense 1 size is nothing but this size. Access the weights of these guys, multiply it with the same x value. That's what I told you, that the same x is given to all of them. Okay, it's not a different value. X is multiplied by wi and bi, because you are trying to find the output of one node. H1 of 0 you want to find, so b0 you want to find. So this is nothing but b1. B1 array is having the biases of each element, so you have to multiply this x with this and add that with bias. Done. That is the input coming to the node finally. Now what you should do? You should do the ReLU function. So call on ReLU this value, okay, and that output is what is going into H1. So that is very straightforward. H1 you understood. Now I have not shown you what is in the ReLU. It is there. ReLU is nothing but it is also inline, so it's much faster. F max of 0 or x. That means if you pass a negative value, you will get a 0. If you pass positive value, the positive value as such will come out. So that is what is the ReLU. We saw that. That output is written into H1. So I hope this code is very, very easy to understand. Simple. Okay. Now come to the next one. Next one, you have H1 value already ready, which is nothing but the input coming from the 5 nodes. Okay. Now you have to, these are the input coming from 5 nodes. H1 of 0 to, okay, 0 to 4. Okay. These are the values coming here. Now this thing you have to multiply and then do the same thing. Here, the way the things are stored in our array is, okay, let me call it as A. If you remember, the same thing is B. So A, B is here, and C and D, okay, that way, okay. So, but whereas you are accessing it for every output, H2 you want to find. So what you should do, you should access this value, then this value, then this value you have to access. Next iteration, you have to access this value, and this, okay. That is how you have to go. I am using, now see this indices, I and J I am using. I am doing it for this, okay. I am using I here, please remember I am using it here, which is because my output is what is this nodes are, so I am using I here, and J I am using the indices into the nodes of the previous layer. So you can understand this was stored originally like this, right? For each row it was storing it. So J is supposed to give us that which element of this you are interested in, okay, and then I is supposed to give us on which node I am working on. Currently I am working on for this layer. Current layer is L2. So keep that in mind. I am coming in to calculate the output, this output, okay, this output from the first node. I am coming in with I equal to 0 because I is going to change from 0 to 1 because it's only 2. H2 of I am initializing it to 0. Now H2 of I is what? This value. Because it's a float and it's a local variable, I always normally better to use it as a float, because if you recall while creating this, okay, it's a lot of things you want to remember. This is running, the whole program is running as a process in the real-time RTOS, FreeRTOS OS on ESP32. Okay, any variable you declare here is you going to use the stack of the process, which is nothing but the 10,000, if you remember, that we gave for creating the processes is what is there. Now what is happening is we are not creating a process, so it's a main process which is getting running. So the stack is the size that is we are giving it for the one process running on the ESP32. So if you can decide based on the number of layers you have and the number of nodes you have, the stack size will be used up when you have this float. Otherwise you have to use it as a static, then it will be using up the data area. Keep it in back of the mind that where you are using the which part of the memory, okay, like a sidetrack. Okay, H2 of I, you are initializing it because you want to compute the value. Initially it would have been used for something else, so I am initializing it to 0. Then I am using the J for accessing the constants for the different values coming to this node, because the values are also different values. You can access it from H1, okay, with J, H1J I can use it because the values coming out of the previous node is coming from H1, but the actual weight also different. So weight I need to access it by using this index, which I explained to you with the inline macro also. So I am passing j comma I here. I am using it as I comma j there. Please understand the difference between that. What I am passing is first index is into the L2 array. Okay. So that needs to be used within this. Okay. The first index is to be used, which is j here, which is to be used to access the individual row element. So let me explain. You have this I is here, j is here. Okay. J. That is while being here. When you go into the function, I am replacing with the j I am calling it as I. So let me explain now. When you go into the W2 function, I am reading the j as I. No problem. Let me explain now. Our friend j has become I here. So I is getting multiplied, which is nothing but our original j what we passed, right, is getting multiplied by this thing. Okay. So why? Because we want to offset it by this much amount of time. Okay. Dense to size, because if it is 2 you have to offset by 2, if it is 3 you have to offset by 3. So that is why it is getting multiplied by this value, and then index into j is the element. Okay. This element, whatever is the particular element you are looking for, so that is accessed while getting it here. Okay. Because index here I is following this. Okay. So index is into this. Okay. That you try to understand it, what I am doing here. So you are accessing this variable, and then what you do, h2 of that you multiply, sorry, you keep adding it, because you have to keep adding the weights with the input values, and then summation is multiplied with the one bias value. Okay. One bias value is b2. Finally you use that value into ReLU to get the h2's output. So most critical or difficult portion is only this. Okay. Then rest of it is simple. Okay. So I think I have already exceeded the time limit, or almost through. I am not sure how many of you are clear. Please read it once again. The code I'll share it today, end of the day. Can you guys do the assignment of 3 layers? First of all, try to use sine model, and then use a full wave model, and then one complex wave model, which I wanted you to develop. Okay. Which I showed you here. That is little more involved. Okay. Complex equation. Where is it? Okay. I don't know. This waveform. Okay. 5 sine squared x plus 4 cos x. Okay. 5 sine squared x, 4 cos x will give you output. Okay. Similar to, I'll show you the output. I hope I clear. Okay. This is the output of that waveform. Okay. And then I developed that on, I will just run it once to show you, okay, how it looks like, the same output. Oh, sorry, I'm running this one. Complex waveform, I need to compile. Okay. 1 second, just before we close, I will show you this output once. You have to change it on both sides to do this complex waveform. Okay. I thought I'll give you that as a assignment for lab 11. Okay. You don't need to, this is a 2-layer only. Okay. 2-layer model, and output will be like this. Okay. 2-layer model, the same. This output is coming here on ESP32. Okay. You can see that this is combined. Okay. This whole thing is joining with this. So that's why you see these two are joining, and then this curvature is there, and then these two are combining. If you join this is the waveform you get. So we can actually do even complex waveform. I will tell you the model what I have used. how many layers. Where is it? Oh, I don't. Okay, I need to show you the model number here. 16 by 16. Okay, 1 second. Yeah, 16. Uh, oh, this is okay. Oh, this is 3-layer model output. I am showing. Okay, I have to check whether I am showing a 2-layer model or 3-layer model. In 3-layer model, okay, this output, if I generate it, I will show you. Okay, it's fine. You can even generate it with a 2-layer model. It is decent enough. Output is coming. I think I developed it on 3-layer model. Okay, if you do 3-layer and then do it on this, it will look like this. Okay, otherwise you will know what the output is coming for 2 layers here. Okay, what do you guys think? Is it too difficult? Okay. Sir, can we store the weights for every node in a layer separately? It will be difficult to manage for a higher number of nodes but here. Uh, what do you mean by weights for every node in a layer? Okay. Oh, that way. Okay, if you can extract it out and store it, it's okay. But you need to, if you make any changes in the generation side, uh, do one thing. Mm, it is very difficult. You have to do the changes on this side also. Okay, I leave it to you. Actually, I'll tell you one thing. Okay, you don't need to follow the same code that I have. Okay, maybe I have not written a proper code. Okay, I'm not saying that I wrote a perfect code. Uh, okay, you can actually, why to do this confusion I comma j, maybe I can change this also to ij and then ij. It's not a difficult thing, right? You can replace this I comma j and do it. So a lot of things you can do. Okay, but the problem is, if you get into trouble, you need to debug yourself. Okay, that's I cannot even I don't know, I cannot look at your code and then debug, because I myself spend a lot of time. I want you to figure it out yourself. Okay, it's a learning experience. Please consider it as a learning experience. It is frustrating sometimes, but try to first take the code without any changes and understand the flow and see whether everything is working fine. And then first step is, you should change the half wave to full wave, and then change the code here to pi you put, because range of values should not be changing from pi now. It's between 0 to 2 pi, and then output it. See the complete sine wave, and then do the complex wave if you want, or some other waveform or something else you can define. Okay, complete flow you do it. And then if you take up an assignment, a complex waveform also you can do it. Okay, 5 sin x, 5 sin squared x plus 4 cos x. Okay, and write that code on this side as well as on the Python side, and then look at the 2-layer model. Okay, one more thing, 5 comma 2 is there, right? Now number of nodes, make it 16 comma 16. Okay, make it larger, because you are anyway generating it, so no issues. So first change you should do is, take this file, make it a halfway to full wave. Okay, then it will not work, because 5 node and 2 nodes will not work. So make it 16 comma 16. Okay, you don't have to change anything. Okay, you can change it in one place, everything is taken care of. You don't need to make any change at all anywhere. So I made it so simple for you. So make it 16 16, generate a sine wave and check. So first get used to this flow, and then try to modify the function itself. First change the function name and see, and then change the nodes, number of nodes, see. So have a proper naming of files you generate, and then you, if you want to change the file name, you need to only change in the output side. Okay, only in this place you have to change. In fact, if you can define as a output file name in the constant there in the top, and then use it here. I leave it to you. That kind of optimization I want you to do. Okay, I'm not saying that this is a perfect code. I could have made it as a constant and then file name, output file name, and then changed it. So do that. Make it better. Make it better than what it is, but don't make it worse. Okay, that's what I expect you to do. Okay, I'm sure there are lots of opportunity to make it better. Okay, very good. One guy is saying I will try. Others are not saying. I hope you guys will try. Okay, guys. Thank you for. See, this is actually will make you ready to go to the industry. I'm telling you. Okay, if you can debug it and do it and still as sane, and then you are living, then you are ready to go to industry and crack your code, you whatever you look at. Okay, attendance, fine. Okay, I'm not saying it is difficult, easy. Okay, but sir, you can say anything. I didn't say. Okay, you can say anything to Chinese. Oh, okay. Okay, so I'm not saying Devashish it is easy, but worth a try. Okay, because you will learn on the way. You will learn a lot. Believe it from me. Okay, do first only 2 level. I'm not asking you to do 3 level. Then venture into 3 level. I'm sure you will break so many things. Stage by stage you have to do. You have to plan it out. Okay, do it. Okay. Okay, fine. What is the time? 06. Bye bye. Good night. I think you have a class next. I'm not sure. Okay, bye bye.